Hello everyone, my name is Ilias Chamatidis from National Technical University of Athens, and I will present our study in the effects of time series length in early warning tsunami systems using a spatio-temporal transformer. Essentially, tsunamis are a very devastating physical phenomenon which is very hard to predict using traditional models such as computational fluid dynamic models. So when an earthquake is happening, we need a fast solution and reliable solution to predict this phenomenon, to issue early warnings in the coastal areas affected. Compared to the traditional models, which need a lot of computational resources to run the calculation, AI can fast infer those connections between the input and the output data, so that makes it a reliable solution to calculate these outputs. In our study, we used the dataset created by Professor Goda in West Canada University, which consists of 3,000 simulations of earthquakes in the middle of the Pacific. And by using the simulation as input data, we try to predict tsunamis and inundation onshore and nearshore. This dataset has earthquakes between 8.2 and 9.2 magnitude, and we have essentially 26 offshore stations and 36 nearshore and onshore stations in the Tofino Island of West Canada. In this picture, we can see all the 36 sensors that were used as an output, which essentially we have the 26 stations as an input, and with a model we try to predict what will happen in those offshore stations. The input that we have, it looks something like this. It's a waveform of 3 hours, which the buoys record in the offshore locations in the middle of the Pacific. And by reading those values, we try to predict the values in the shore of Tofino. And the model we use for that is a transformer, which are powerful models that the past 5 years are used in many situations, and we feed these time series of the offshore location in the model, and we try to predict the onshore outputs. To make this model useful in early warning scenarios, which we need a part of the whole waveform, not the whole waveform because it will take 3 hours, we need immediate response. We train the model with the whole waveform, and then we use percentages of this waveform to predict an independent testing with a test set and see the capability of the model to act as an early warning system in these scenarios. Here, for example, we have a result of our model trained with a whole waveform and its ability to predict the wave height, which is the orange line compared with the blue line, which is the ground truth, and similar the speed of the wave, which is called wave flux, which is when it's near shore. We can see with the red the predicted speed, and with green the ground truth. We see that our model can predict very good both of them, and the next step is to give the model parts of the waveform to see its ability to predict the early warning ones. Here we see that when we give percentages of the original waveform, as the percentages increase and we give the whole waveform, of course we have a better performance, but we see around 30% of the original waveform we have a very good performance around 2.2, 0.2, 0.3 root mean square error, and similar we have a very good increase in performance around 60% for the speed. In conclusion, we see that the transformer has a very good ability to predict both wave height and wave speed onshore. We have a lot better performance in wave height, and that's because we have these buoys that record the waveform and the wave speed. And there are cases that we don't have wave height increase, but we have a constant wave speed because it's a different recording than the other one. And the main and very good conclusion of this study is that this transformer, as we see in the previous diagram, can act as an early warning system even with a small portion of the waveform, which that means by having these fast prediction times, these systems can be installed and having constant input from those buoys and predict if there are some imminent tsunamis near shore or onshore based on the input. For example, to choose a good percentage of points that we have as an input, it would be around 30%. We would change some accuracy for the speed and choose the 30% to have in our model and have this in our final model for the predictions. Thank you for your time.